Life is becoming faster and more flexible. Individuality is the buzzword. Over 100 million additional goods consignments in Germany alone. This logistical challenge calls for a new approach to a solution. The Internet of Things, predominantly conceived by two leading German researchers and a consortium of logistics specialists. You see, the world is like a huge anthill. If you look at it from further away, it could certainly appear like this, and that is just the way the Internet of Things is organized. On the basis of limited information, targeted material flows are organized independently. That is the Internet of Things. The research project Internet of Things takes a totally new approach. In fact, it introduces a paradigm shift in logistics. Farewell central hierarchical systems, welcome decentralized, highly flexible systems. The concept has been first implemented in intralogistics. The rapid delivery of niche products as well is the challenge here. Yet current systems soon encounter their limits. Conventional intralogistics is very rigid. This represents the major challenge for the Internet of Things project. In other words, to achieve maximum flexibility. Until now, intralogistical systems were individually planned for each application location, then installed and commissioned there at significant expense. The systems are unique. If the requirements change, a conversion will be extremely expensive. Nowadays, it's not worthwhile converting a larger intralogistical project, at least if you convert it on a large scale. It's cheaper to completely rebuild it. In 2006, the Internet of Things was only an idea, but an idea with tremendous potential for the logistics sectors in the export nation of Germany, and hence also of great importance to the Federal Ministry for Education and Research. With over 3 million euros, the Federal Ministry for Education and Research consequently assisted a consortium from science and business with the goal of researching the feasibility of the Internet of Things. When we began the project in 2006, it was an essential aim to reduce this expense. We have therefore developed a new modularization concept comprising a mechatronic module. Mechatronic means that we build this module up from mechanics, control technology and electrics components. Mechanics, logic and energy are bundled into one unit, a so-called entity. That also makes it much easier to connect modules to one another in any order, because the interface actually no longer exists. The information is communicated with the product beyond the interfaces. This has the major advantage that this mechatronic module can be engineered, tested and commissioned without the entire unit having to be tested. After the plug and play, the new module is recognized by its neighbors and can hence be actuated in the entire system. This gives rise to a type of map. As with the colony of ants, the consignment becomes integrated in the overall system. The entity receives the destination and route data of each individual consignment and communicates this flexibly as a control to the next transport module without a central computer. If congestion arises somewhere or a section is closed off, the next best alternative route is automatically calculated. To enable the consignments to arrive autonomously at their destination, you need a powerful chip which can also communicate with its environment. RFID technology is a very significant component in the concept of the Internet of Things, as it's possible to give the transport item information as well and allow it to make independent decisions. The chip can receive information and save or send data via electromagnetic waves that provide the necessary energy at the same time. In test systems throughout Germany, the consortium has developed and tested the material flow technology, as well as universal software and control architecture. Products will result directly from this. These include control elements, smaller control components that are precisely customized to our requirements. A whole host of software has resulted, but above all, reliability has resulted. Yes, the Internet of Things functions. But does it also work in large systems? To test this, the decentralized logistics was simulated at a major airport. We have undertaken one of the greatest challenges in intralogistics, namely airport luggage conveyance, having simulated a system with a peak load of over 10,000 items of luggage per hour there. The result? The Internet of Things can successfully control such systems decentrally. And, what is more, the extra expense for communication resulting from the decentralized system can effectively be overcome with modern technology. For the logistics location Germany, the Internet of Things is a pioneering technology whose logistical architecture has now been successfully developed. In funding it, the Federal Ministry for Education and Research has contributed to the success of the project. The task ahead is to implement this new technology in products.